This time we'll be looking at Ohm's law. When we talk about electric current, is a law. Ohm's law is a law that governs the flow of charges through a circuit. But before we talk about this Ohm's law, we need to understand certain terms like resistance. We understand volts, H, we understand conductor, insulator. So these are some of the terms that we need to understand. Let's start with a conductor. Is a material. When we talk about conductor, is a conductor of electricity. Any material that allows the flow of charges freely is called a good conductor of electricity. Metals are good conductors. And then when you talk about an insulator, is that material that do not allow the passage of electrons freely. They do not conduct freely. We call them insulators. Things like rubber, glass, dry wood, and so on. So these are what we mean by a conductor and insulator. Then what is a resistance? The ability of a resistor, a material to resist the flow of current, is what we call resistance. And that resistance is measured in ohms. Voltage is the potential difference between 2 points in the circuit. Voltage is a potential difference between 2 points in the circuit, and it is measured in volts. And what is potential difference? Potential difference is the work done in moving a unit charge from one point to another in the circuit. The work done in moving a unit charge from one point to another in the circuit is what we call the potential difference. So these are some of the terminologies that we need to be familiar before we talk about Ohm's law. And what is electric current? Electric current, I, is the rate at which electrons move around the circuit. You can say that current is equal to Q all over T, where Q stands for charges or the charge in coulomb and T time in second. And the unit of current I is what we call ampere. Ampere is the unit of current. So having known this or defined these terms, we can talk about Ohm's law. But before we talk about Ohm's law, let's look at the circuit symbol. Circuit symbols of this current. When you talk about resistor, talk about a resistor. This is a symbol for a resistor. And we have two types of resistors. We have what we call a variable resistor, and a standard resistor. Variable in the sense that the resistance can be varied. For example, you talk about rheostat, you talk about resistance box. These are the resistors that their resistance can be varied, can be changed from one point to another. So when you talk about a variable resistor, the symbol is like this with an arrow. Remember, some authors will write it either this or this. So if it is a variable resistor, you have an arrow on it. So when you see this, you should know the meaning. Then when you talk about this symbol, it stands for cell. Remember, the longer side is always a positive and this is a negative. So these are some of the terms and symbols we need to know. So let's define or state Ohm's law. Ohm's law states that there's a relationship between current and potential difference, or relationship between potential difference and current. So we can say that voltage or potential difference is directly proportional to the current. And we can say that V is equal to I R, where V equal to the potential difference. Alright, PD means potential difference in volts. I is the current in ampere, and R is the resistance in ohms. And this is a symbol for ohms. So we can say that Ohm's law states that the current passing through a conductor directly depends on the potential difference. And this is a statement of Ohm's law. So if you are asked to calculate the potential difference, you'll be given current and resistance. Now from here we can say that V is equal to IR, I is equal to V all over R. I make I the subject by dividing both sides by R, and you have this. And we can say that I will be equal to what? V all over R. So what are the implications? It means that if the resistance of a conductor is low, higher current will be allowed to pass through it. And that's what we call a good conductor. If the resistance is high, small value of current will be allowed to pass. I would say it's a poor conductor. So these are the implications. So you know a good conductor when it offers, a good conductor allows currents to pass through. The resistance is low. For a bad conductor, the resistance becomes high and small amount of current will pass through it. So in our next class, we'll look at how we can use this formula to solve our problem.